Hello everyone, welcome back to my channel. Today we will be solving Leetcode problem 2064. Minimize maximum of products distributed to any store. Okay, you are given an integer n indicating there are n special retail stores. Okay, we have n special retail stores and we also given there are m type of m product types of various amount which are given as zero indexed integer array quantities, where quantities of I represents the number of products of ith product. Okay, we have been given a quantity array, so we have like product 1 we have 11 quantities, product 2 we have 6 quantities. Okay, you need to distribute all the products to the retail stores following these rules. Okay, a store can be given at most one product type but can be given any amount of product. For a given store we can only give one type of product. Okay, we cannot give two different products to a same store. Okay, if I'm giving apples to the first store, I cannot give bananas to the same store. Okay, if you have apples of 11 quantity and bananas of 6 quantity and we have 6 stores, we cannot give apple and banana to the same store. We have, okay, after distribution each store will be given some number of products, let's say x. Okay, x represents the maximum number of products given to a store. Okay, x represents the maximum number of products given to a store. You want x to be smaller as possible, that is you want to minimize the maximum number of products given to a store. Okay, let's jump back to the editor. Okay, I'm back to my editor. Yep, so we have basically 6 stores and we have basically 2 products of quantity 11 and 6, right? We want x is the number of jump back to here, x is the number of products given to a store. Okay, x is the number of products given to the store. Okay, and we want to minimize this. Okay, so how can we minimize this? Okay, let's assume, let's go through some examples. Okay, we have basically 6 stores over here and let's say we are giving let's say we are giving all the 11 products to the first store itself. Okay, x is the number of products given to a store, so we have given 11 products to the first store, so I'm done with all my p1 products. So I have to give one product to this one product of p2. Let's say this is p1 and we have p2, so I will be given p2 over here, one product and 2 products. So we have allocated all 6 products of p1 over here and all 11 products of p2 over here. And if you see the number of products, so we have given 11 products to the first store. So let's take another combination. Okay, let's say we have given 5 products of p1 over here and 6 products of p1, so total there are 11 products. And let's say we have given 2 products of p2, one product of p2, one product of p2 and one product of p2, which is basically 6 products of p2, right? If you see the maximum product which we are given here is basically 6 products. Okay, a store has got 6 products. Okay, so still we can minimize this. Okay, let's try to take another example. If we give 3 products of p1 over here, 3 products of p1 over here, 3 products of p1 over here, we have done with 9 products and we can give 2 products of p1. Okay, and for p2 we can give 3 products to this 5th store and 3 products over here. So we also done with all p2 products as well, right? So if you see the maximum products given to any store is 3. Okay, so here the x value, optimal value for x is 3, right? 3 is the minimum value and it is the maximum number of products which can be given to any store. Okay, 3 is the maximum number of products given to any store in this particular combination. Okay, so like how can we approach this problem? Okay, so let's say we have x, let's say we have X products with us, and we have n stores and some number of quantities we have. Can we determine whether we can distribute these products, whether it's optimal or not? Let's not think about it. Let's just think whether we can distribute it or not. Okay, how can we approach it? So like X is the basically maximum products a store can have. Okay, let's say X is the maximum products a store can have, right? So a store can have less products than X, but it cannot have products greater than X. Okay, that is what we are saying. Okay, this is I hope you got this particular point. X is the maximum products a store can have. It cannot have products greater than X. Okay, let's take an example. We have 6 stores over here and we have 11 and 6. Let's say X has 4 products. Okay, at any point of time for a given combination, any store cannot have a product greater than 4. So let's take the stores. So at any point of time I have total 11 products. Okay, so I can allocate 4 products, maximum 4 products to the first store. Still I can still allocate 4 more products. I have done with my 8 products of P1. Still I have 3 more products, right? I can still allocate all my 3 products to the following store. Okay, and I cannot allocate one more product of P2 over here. Okay, it will violate the constraint which they have defined. Okay, I cannot allocate one product of P2, so I will basically go to the next store and try to allocate the remaining products I have. So I will allocate 3 more products of P2 over here. Maximum I can allocate 3, and maximum I can allocate 3 over here, right? So if you see, one store has been left empty without allocating any products. Okay, so this is not a valid combination. Okay, so we want to allocate all our stores, and every store should at max have 4 products. Okay, so here I can actually allocate 4 products over here, and here I can allocate 2, but still we are left with one more store over here, right? Whenever we are trying to allocate a product to a store, we'll allocate the maximum products which we can allocate. So in this particular combination, there are still a store which which we are not able to fulfill with any product. So this is not a valid combination. Let's say X is equal to 3. So I will basically try to allocate maximum 3 products to each store. Okay, so I can allocate 3 products to the first store. I can allocate 6 P1 products were done. I can still allocate 3, 9 were done. I can allocate 2. I only have remaining 2, so I will allocate all 2 products to this. And next I will allocate 3 products of P2 over here and 3 products of P2. So I have basically allocated all the products to all the stores, and I basically fulfill my criteria. And so here the 3 is the minimum value. Okay, minimum value for X. Okay, so idea is to minimize the value of X, right? So X can basically go from a certain range to certain range, right? So I can what I can do, I can allocate 1 product to a store, right? I can allocate 1 product to each store, right? And maximum how many products I can allocate to a particular store. If I have 11 products, right, whatever would be the maximum among all these products, I can maximum allocate those many products to a particular store. So in this case, 11 is the maximum products which we can allocate to a single store. Okay, now so if you see the search space, it is 1 2 3 4 5 6 7 8 9 and 10. So X can basically go from all the way from 1 to 11, right? So this is a search space. We want to identify the minimum value of X, right? So here we can actually take help of binary search and try to shrink the space at any point of time. Okay, so initially left would be this and right would be this. Okay, and mid would be somewhere around 11 by 2, which is 5. So this would be mid. Okay, so if I choose X as K, can I distribute all my products to all the stores with 5 is the maximum products which I can store. Can I actually distribute my products to all the stores with 5 as the maximum products which each store can store? Okay, if it is yes, then still we have to look for a smaller value of x, right? The idea is to minimize the value of x. In that case, we will basically look in the left space. If we can allocate, I'm repeating over here, if we can allocate maximum 5 products to each store, okay, in that case there is a possibility that we can still allocate lesser number of products for a store. So in that particular scenario, we'll try to search in the left space, okay, which is over here. If we cannot allocate with 5 products, maximum 5 products to a store, that means we have to increase the minimum number of products which we can allocate to a store. In that case, we'll basically search in the right space. Okay, let's jump back to our Leetcode. Okay, yeah, I'm back to my Leetcode. So let's try to implement the solution. So firstly, we have to identify our search space, right? So what would be the search space? Search space would be from 1 till all the way till the maximum element in the quantities, right? So let's say max, let's say it is maximum number of max products is basically, initially it would be 0, and we'll basically iterate in our quantities. For each quantity in our quantities, I will basically update my max products, okay, which is quantity comma max products. Now that we have updated the max products, so our search space would basically be from 1 till the max products. Okay, now we will basically do certain tasks. Okay, so what would be the mid would be left plus right divided by 2. So if we can allocate mid number of products, that means we have to actually look for a lesser number of products which we can allocate, right? That means we have to decrease our search space and we have to search in our left space, okay, which is basically in that case right would be mid -1. If we cannot allocate, in that case we have to actually increment the mid and we have to distribute a higher number of products. In the end, we can simply return the left. Okay, now that we need a function, if you see we have a placeholder here, we can whether we can allocate or not. It's basically, can we allocate mid number of products? Okay, let's have a boolean. Let's say can allocate. It will basically take the number of stores we have, and it will basically take the quantities, and it will also take the maximum products which we can. It will basically take the products, number of products. This function will basically tell whether I can allocate these many products to these stores or not. Okay, so initially what I will do, I will let's have a variable called remaining products. In the starting, I would basically take the first product quantities, and those are the products which I have to allocate in the initially, right? So now we will be basically iterating. We will basically go to each store, right? So we'll have a variable which will basically tell at what store we are currently dealing with, and we'll also have a variable called what product we are actually dealing with. Initially we are dealing with the product 0, okay, which is the first quantity, and we will go till, let's call it a store number, okay. So if this, we have to go till all the way till all the stores, and yeah, so if we have products, okay, if we have products which are, if we have products which are greater than the number of products which we can distribute, okay. So for a given store, I can basically allocate these, let's say let's take the number of products as 3, okay. So initially I have 11 products, out of which I can basically allocate 3 products. We have more number of products with us, and maximum we can allocate to a store is basically 3, okay. So let's rename it as max product, okay, that would be more readable. So we can maximum allocate 3 products to the store, right? So I will basically still, I can allocate all 3 products to the first store, then I will be left with remaining products would be the number of products which are subtracted. We have to subtract whatever we have allocated, and once that is done, we will basically go to the next store, okay. And again we'll again check whether are we left with any number of products, right? So if once we have allocated, we'll simply continue, we'll basically go to the next store, and we'll again check whether whatever products we have, are we greater than the maximum products which we can allocate or not, okay. If yes, we again will continue. If that is not the case, right, if we have a product which are lesser than the maximum products which we can allocate, in that case whatever products we have, we will allocate to the particular store, okay, and we'll basically move to the next product. So since we have to move to the next product, we should actually increment our product number, right? Now once we have incremented our product number, okay, so we have to check, have we allocated all our quantities so far, right? Just check, have we allocated all the products, okay. The product which we are looking at is actually equal to the length of the quantities. If that is the case, then we should simply return true, okay. If that is not the case, that means still there are certain products which we have to allocate to the store. So in that case, the remaining products is actually equal to the quantities of the product number, okay. Now we'll basically take the next product, and we'll again try to allocate the things, okay. Now we have allocated for all the stores, and still if we have left with some of the stores some of our products, okay, that means we cannot, that's a wrong combination, okay. Then we'll basically return false in that case, okay. So let's try to put it over here, can allocate and number of stores, quantities, and the mid. Yep, let's try to run this solution. We got some typo over here, I guess, over here, can't find quantities. I think it's in the line number 4, okay, here, okay, typos. Yeah, I think our solution has been accepted and all the default test cases were passed. Let's try to submit the solution. Yeah, it also satisfied all the test cases. Yeah, I hope you have understood the problem. do subscribe to my channel for more such coding videos. Thank you.